So below are the graphs f of x and g of x. X squared plus bx minus 3, that is going to be a quadratic function. It's a parabola. And g of x is equal to a over x plus p. That has the standard formula of a hyperbola. So f has a turning point at c. So c is going to be the turning point. How do we calculate a turning point? Well, x is equal to minus b over 2a. Whatever we get for x, we just sub back into the original equation to get y. And it passes through the x-axis at 1 and 0. So that is going to be an x-intercept. D is the y-intercept of both f and g. So D is the y-intercept of the f graph and the g graph. And the graphs of f and g also intersect each other at E and J. Point of intersections here between E and J. Now the vertical asymptote of g passes through the x-intercept of f. Vertical asymptote of g has an intersection there with the x-intercept of f. 4.1, write down the value of p. So p here would represent our vertical asymptote. So it's going to be that dotted line all the way through. It's a positive 1 here. So in the standard formula, it's always indicated as a negative. So p here is equal to minus 1, as it has been indicated here as a positive. If it was on the negative x-axis, if that was a negative 1, p would then be a positive 1. It's always the opposite, the inverse. 4.2, show that a is equal to 3 and b is equal to 2. There's a, there's b. So our little calculation for a, we are going to use the formula. Y is equal to a over x, and we calculated that p is equal to negative 1, so minus 1. And we can use any point on our hyperbola that we know. We know what d is. How do we know what d is? Because that is the y-intercept here of our parabola. So we know that d has the coordinates of 0 and 3. It's a y-intercept where x is equal to 0 and the y value is equal to, negative 3, my mistake. So we can just sub that in here. So negative 3 equals a over, the x value was 0, 0 minus 1. Therefore, a is going to be equal to 3. How did we get there? Well, minus 3 equals a over minus 1. Minus 1 times minus 3 is equal to positive 3. Therefore, 3 is equal to a. We just rewrite it neatly as a is equal to 3. And to get our b value here, we can simply sub in any point on the parabola. We can use our x-intercept here that has been given, and we can just sub it into f of x. So we're subbing in 1 and 0 into f of x to calculate our b value. So 0 equals 1 squared plus 1b minus 3. Okay, so 0 equals 1 plus b, positive b minus 3. We isolate our b value, we take it over to the left-hand side, so it becomes a minus b. 1 minus 3 is equal to minus 2. Divide both sides by minus 1, and we get a nice answer here of b is equal to 2. Next, calculate the coordinates of c. So c here, that is our turning point of our parabola. So like we said, we can just use x is equal to minus b over 2a. Our b value, we just calculated it. It is minus 2. So minus, and then 2 in brackets, over 2a. The a value is just equal to 1. Nothing has been indicated there. It's just x squared. So that's like the invisible 1. So 2, open brackets, 1. Minus 2 over positive 2. That's going to be a negative 1 answer. And we sub negative 1 back into f of x. Subbing our negative 1 in there. It'll look something like this. So y equals, just wanted to clear that up. Y equals, open a bracket, minus 1 squared plus the 2 that we just calculated, minus 1 minus the 3. Okay, so we're just subbing it in here. And we get an answer of negative 4. Therefore, dot, dot, dot. C has the coordinates of the negative 1 here and the negative 4 there. That's the x value, that's the y value, and that is what the answer looks like. Okay, so that was 4.3. Last question, 4.4. Write down the range of f. So the range of f, that would be the range of our parabola. I'm using black now, I'm just going to do the answer here. Well, when calculating our range, we always utilize our y turning point. So the y turning point is absolutely key here. And given that our a value is positive, it's greater than 0, our range is going to be y is greater than or equal to negative 4. So When calculating the range of a parabola, you first look at the y turning point. That's absolutely key, right? After you've established your y turning point, you have a look at whether a is negative or positive. A is equal to 1 there, so it's positive. So y is going to be greater than or equal to -4. But if a was negative, y would have been less than or equal to -4. So it all depends on your y turning point, firstly, and then a. So if a is positive, y is positive. If a is negative, y is negative. And that's it.